Today, astronomers have opened a stunning new window on the universe. As we peer ever deeper into space, we travel farther back in time.
This idea that we can map the universe and see its history is a testament to our imagination and our desire to explore.
How far away are these things? Are they little dwarfs nearby, or are they star-forming protogalactic subfragments? What are they?
Now to a distant horizon we venture, to the very brink of time and space. Its stars number 100 billion. It is so vast, it takes 70,000 years for light to travel across its expanse. For more than 100 million centuries, it has defied the eternal night of space. Our Milky Way is but one galaxy out of billions of others. And yet, behind its luminous veil, amid the chaos of gas and stars, is a small wonder. Nine tiny planets united by little more than their orbits. In their embrace, a star of no particular distinction. Within their sphere, a world of singular importance.
Yeah, but we're getting there.
As far as we know, our planet Earth is the one place in all the cosmos where creation has allowed itself a few admirers. Chief among them, the Garland family of Fort Worth, Texas.
Shelley and I first started coming out to the Davis Mountains when we were still in college. And we were first introduced to the mountains together. And the nighttime skies right out here at the state park.
15 years ago, Shelley and Don Garland helped organize what has become the largest gathering of stargazers on Earth. 150 miles from the lights of the nearest city, the Texas Star Party will take place under night skies as dark as any in the United States. For 6 nights each spring, up to 700 stargazers descend on this remote cattle ranch to roll out their telescopes.
Welcome to the Dust Bowl, the Texas Star Party.
They come geared up with precision mirrors and equatorial fork mounts, sophisticated computers and star tracking software. The sky's the limit.
This is the most exercise you get in the course of an evening, is taking the top off. There's no hangover. I don't kill off brain cells. I'm with a great group of people. I can't think of a better thing to do.
The Ring Nebula, Jupiter, Venus, M13.
For the Garlands, the Star Party is part vacation, part pilgrimage. This trip marks an important rite of passage.
Yes!
Yeah!
10-year-old Ian has attended every year of his life. This year, he'll get his first telescope and take his place amid the community of amateur astronomers.
There's a lot of things out there that people never realize are out there. Just seeing these points up in the sky that don't really mean anything except they're just white dots. But there are all kinds of things out there that are just unbelievable to see.
As night approaches in West Texas, 1,000 eyes are at the ready. For stargazers around the world, the secrets of creation are emblazoned across the heavens. But even as the universe beckons us to explore, it also challenges us with its incomprehensible distances and staggering voids.
As we discover more and more, and the universe seemingly gets larger and larger, more complex, vaster, there's a tendency perhaps to think that humans' role in this diminishes with time. But for me anyway, it's like learning my world better. I feel larger the more I understand. I don't understand the purpose of it all at this point, but at least I begin to understand my place in it.
Today, the science of astronomy is being transformed by a new age of technological advances. On mountaintops around the world, scientists are opening ever larger telescopes, capturing light from ever more distant reaches of the universe. That light may have traveled millions, even billions of years to reach us. By the time it does, it offers a window into the distant past.
These giant telescopes, they are the only true time machines that human beings have. And they are totally faithful. There's nothing hokey about this. You look through a giant telescope, you get a view of a very distant region of space, and it is as though you were a historian and could put your eye to a telescope and actually see Hannibal crossing the Alps and all those elephants trotting along. We are actually seeing the universe and the things in it behaving as they did billions of years ago.
The deeper into space we peer, the farther back in time we venture. This notion that we can study the history of the cosmos is only a few decades old. Early in this century, astronomers believed that the universe was eternal, infinite, and unchanging. Our solar system, they found, is nestled within a flat, rotating disk we now know as our galaxy, the Milky Way. But they envisioned our galaxy as the whole of the cosmos. Beyond lay only the blackness of space. Albert Einstein, for one, defended this model of a static universe, but he recognized an implicit flaw. Gravity ought to cause stars and gas to collapse into a common center. Instead, he proposed an unknown repellent force somehow keeps them apart. This vision was about to be shattered. In 1917, after 15 years in construction, a powerful new telescope mounted on a summit above Pasadena, California, was opened. The Hooker telescope was hailed as a technological marvel. At 100 inches wide, its mirror was by far the largest ever built.
100 years ago, there was a feeling that if you just got enough money together and built a bigger telescope, then you'd see further and it would just be more of the same. What happened with the 100-inch telescope is that it was a lot more than just more of the same. In fact, it was a fundamental reappraisal of the nature of the universe.
Among the parade of astronomers, a young newcomer arrived fresh from service in World War I. Edwin Hubble was interested in mysterious cloud-like objects known as nebulae. He turned the new telescope on the fabled Andromeda Nebula.
Andromeda was very important to Hubble because astronomers were wondering what all these little fuzzy blobs that we now call galaxies were. And there were lots of astronomers who thought that they were small little things that were just pieces of the Milky Way. But Hubble was able to discover stars in Andromeda that he could see were very much like stars in our own galaxy. And at that point, everything clicked into place. He got the scale, he could see that it was far away, it was big. There was no way that it was a little piece of our own Milky Way.
Hubble discovered that the universe contains other galaxies, that it's far larger than we dared imagine. But he didn't stop there. He analyzed the light of distant galaxies and found that it skewed slightly to the red. This redshift is the result of the Doppler effect. It's like the sound of a train whistle that changes pitch as it speeds past. The redder the galaxy's light, the farther away it is, and the faster it's moving away from us. The universe, Hubble found, is not static, but expanding rapidly in all directions.
And it expands according to a very simple law, and I have a tiny piece of the universe here that shows that. So the black elastic here represents the stretching space of the universe, and these stars represent galaxies. So if I stretch the universe, the galaxies move apart. They recede from each other. The universe is expanding. And they recede from each other in such a way that the velocity is just proportional to their separation. So if I sit on this guy, this moves at some velocity, this at twice that, this at 3 times that. And it's the same for this guy. This guy moves at velocity v, 2v, 3v. Anywhere I sit, I see the same law.
The importance of Hubble's discovery eluded most of the world, but not one visitor.
Dr. Einstein, who gave the world its biggest headache, is back in California again with his wife. Now he is going to the Institute of Technology in Pasadena to work with other distinguished scientists.
In 1931, Einstein lent his prestige to Hubble's discovery. He conceded that his own model of the universe was wrong. It was not a repellent force that kept the universe from collapsing, only its relentless expansion. News traveled fast, all the way to Hubble's hometown paper in Missouri.
In my mind, there's no doubt that Hubble's discovery that the universe is expanding was the most important scientific discovery of this century. And the reason is that without an expanding universe, it's impossible to make sense of the idea that the universe has a finite age, that it came into being a finite time in the past.
This discovery had a profound consequence. If the universe is getting larger, we can make a movie, a cosmic movie, and we can run it backwards. It would look very comical. All the galaxies would be getting closer together. And we can see that the expansion of the universe implies that there was a first moment, a Big Bang.
It was long assumed that the Big Bang created a sprawl of galaxies spread uniformly across space. That it might instead have a more complex structure seized the imaginations of scientists. Among them, Margaret Geller.
Here's a nice.
That's a nice case.
You can ask lots of questions in science that you can't answer, either because the technology isn't there, or because you just haven't defined it well enough. So if you ask, what does the universe look like? The universe is huge. So what are you going to do? I mean, you have to figure out how to map a little piece of it wisely chosen so that it will tell you something in answer to a very precisely defined question. It's hard to imagine.
We still have to,
That question for Geller and her colleagues was whether a narrow slice of the universe could reveal a pattern on the largest of scales. She set out to actually begin mapping the universe.
We mapped the distribution of galaxies in this first slice of the universe, not expecting to find pattern because the prejudice was the pattern wasn't there. And when we plotted the data, we saw this pattern, which has become very famous. It's known as the stick man. So here you can see that there's a very striking pattern. There are large empty regions where there are very few galaxies, and these regions are 150 million light years across. But most of the galaxies are in thin structures which surround or nearly surround these empty regions. And I must say that the experience of seeing this very striking stickman pattern was a kind of thrill that I think people are very fortunate to have once in their lives. And you just wonder why, how could it be that you are one of the first three people to see this?
Geller's first wedge extended roughly 700 million light years into space and contained 1,000 galaxies. They skirt the perimeter of vast, empty spaces, which she likens to bubbles. But is the pattern in Geller's slice a fluke or a phenomenon? She set her sights even farther afield. Now, more than 7 times the galaxies are plotted over a wider area. They are drawn in expansive sheets of matter that encircle enormous voids.
I think that there is some kind of fundamental human attraction to patterns in nature. Many times when I've given public lectures, especially to young people, I ask them whether they would prefer, suppose they could design the universe any way they wanted, how would they stick galaxies around in the universe? Would they just throw them out like grains of salt, or would they make a pattern? And every single audience I've ever talked to, they all want to make a pattern.
How did the universe gain such definition? The answer is written in microwave radiation that bathes the Earth from all directions, the afterglow of the Big Bang. There were slight variations in the density of the primordial gas. Over time, gravity amplified them and drew matter into a vast web. Cosmologists are using their newest tool, the supercomputer, to envision how the universe then evolved. Out of patches of stars and gas, galaxies began to coalesce. While the universe as a whole expanded, gravity held these evolving star systems in clusters. Some merged or were swallowed by others. To this day, violent duels continue to erupt between galaxies. Their immense gravity sets them on a collision course. They cross paths, leaving behind vast trails of stars and gas to mark the encounter. In the aftermath, whole new galaxies emerge.